Hi, my name is Robin Tour, and I'm going to show you a little do-it-yourself project that I put together for people that might be interested. Basically, what it's going to do, it's a little unit. It's driven by an ESP32 chip, an Arduino chip, and it has an optional real-time clock in it with a little screen here. So this screen is a 1602 LCD screen, so that means 16 columns by 2 rows. You can get them bigger, you can get them in another size, which is 4 rows and 20 columns. And what this is going to do is it's going to show you from your Windows computer the percent busy of the CPU for each core too. So I've got 8 cores on my machine. So this one's showing only 7 cores. One of these cores is actually reporting in at 0 right now. So that's why you're not seeing the graph here. And so it'll show you the kind of the performance level of each CPU, as well as the temperature. So now this temperature is in degrees Celsius. You can have the C there as well. It's optional. I'll show you that in a while. Or you can have that reported to you in Fahrenheit with an F there as well, which would be optional. So I'll just show you a little very short video of that in action, so that we kind of know what we're talking about. So you can see the various bars going up and down there, and that's the percent busy, and the temperature is pretty stable. So that's kind of what we're dealing with. And without further ado, I'll just go in and talk to you now a little bit about the hardware that you need. So 3 pieces, an ESP32, this is a DOIT Devkit 1, as well as, so that's the kind of the CPU of the side of the thing. This is your LCD screen. It's got an I2C board module, I guess, soldered on it. You can get them separate, or you can get them welded or soldered together, if you will. And you know, for the sake of the 10 cents that they charge you to put it on the board, you might as well just get it soldered up. I've got them both ways, but you know, quite frankly, it's just as well to get them soldered up. And this is a real-time clock, and there's a battery that goes with that. And so now I'm gonna, and then this is, you can refer back to this picture if you want, although there's wiring instructions in the document. It shows you how to hook things up. Basically, this unit here works on 5 volts, so you connect the ground and the 5 volt VIN pin to the ground and the 5 volt VIN pin on that side of the board. This guy here works with 3.3 volts, so you connect it on this side of the board to the ground and the power there. And both of these need to get to your SDA and ST S-clock pins on the board. Unfortunately, this board only has one of those, so what we're going to do is we're going to just kind of take these wires. This wire is the SD is the clock one, so it comes in here, and then I join it up, and then I split it out, and it goes to this one and this one. And the same thing, this is the SDA pin, so the SDA pin goes, the wire gets joined there, and then it goes to here and here, and that's really all the wiring you need to do. So where will you get these? So you can get these, I get them usually through AliExpress. It takes a good long time to have them deliver, but you really can't beat the price. So those are the prices, like $5, $3, and that's in Canadian. I'm Canadian, so that's the Canadian prices. And $7 for the real-time clock, but that's for a pack of 5 of them. But the batteries are not included, so they won't ship you batteries from China. So you have to get these from you know, local hardware store or Amazon or something. They're the 2032 lithium batteries. So I'll just go to these sites. Just so here it is here. So what you want is the this unit here. It's the 30 pin unit. So 15 pins on each side. What I like about it is it's got the little mounting holes, which I make use of in the case. and so that's again, that's like $5 Canadian. Let's see what else we got here. We have the LCD. So here it is, LCD. You can get either blue or green. I prefer the green myself, but I just want to make sure that you get this, get one with the module already soldered on here. So, you know, again, $2.50, not a lot of money, Canadian, for some anyways. And, you know, I'd say work with that. And then here's the real-time clock. And so this is a pack of 5 of them, pack of 5, where 5 pieces for $7. And then so it has the, on this side, that's where you put the, you just snap the battery in there. So you need the battery's not included. So there you go. I'm going to have these links on my website here, arlatour.com, CPU monitor JR, Junior. It's not set up yet. I'm just making this video first. And then there you go. So the next thing you're going to need to kind of put all this together is the software for the Arduino and the software for the on the Windows side. So if you go to GitHub at this location, Rob Latour CPU Monitor Junior, what we will find is all the source code that you need to make this happen. So there's really 3 pieces in here, and I'll walk you through them in turn. The first is the Arduino code. How you get this, you just go here and you click download, and you download it to your download folder and unzip it. But there's the Arduino code is in here. There's some extra files here because sometimes I use a Visual Studio to create it. But basically, when you download it, this is the Arduino Sketch that you're probably familiar with. That's all you need there, plus the libraries, which I'll talk to you about in a minute. It also has in it, just back up here a bit, it has, this is the code for the Windows side of things. It also includes a digitally signed executable, so if you don't have Visual Studio, you'll be able to just download this and, you know, get at the actual program that you need to install. So there's the program there. So if I was to download that here, it would be, and then look at it, it would be digitally signed. Let me just take that one file and download it and show you. So there it is there. Show in folder, open up. So properties, there it is. So digitally signed by me. So there you go. But the source is all in behind it too, and it's not obfuscated or anything like that. So you can decompile it if you want to do that for sure. And then the last thing is in this download suite here, if you will, or this package. There's some files that I'll talk about a little later for 3D printing, but I'll skip that and leave it to the end because not everybody has a 3D printer, and probably not everybody wants to listen to that. Okay, so those are the pieces. So when you download it, what you'll get is that kind of that suite of software, if you will. So the first thing that you'll probably need to look at on the Arduino side, on the ESP32 side, is the Arduino Sketch. So here it is here. So you know, there's all the code. You can read through it, see what it does. I've commented it, you know, where I could, where it makes sense. At the top here, what it's going to say is, you know, how to wire it up, which I've kind of covered already. These are the libraries you're going to need. So that's the one for the real-time clock. This is one that you're going to use, and so this one is the library that you probably don't already have installed that you'll need, and that allows it to communicate with your Windows machine, and that's done through something called the WebSocket. And this is for your liquid crystal display. And here are some options you can set. So this is where you'd enter your Wi-Fi router name sort of thing. This is your Wi-Fi password goes in there. This is in terms of the LCD. It's set to 16 columns by 2 rows. That's the address for it. If you don't know, that's generally the address for kind of out of the box, but there's software that you can get called and you just Google for it, I2C scanner, and you can download that if that address isn't working for you. This is some stuff that it has to do with how the two units kind of communicate with each other. So you can change that if you want, but just leave it alone and it should be okay in most cases. Report in Fahrenheit, true or false. Show temperature units. So on the screen there, I don't if you remember, but it had a little degree sign. You can have a C or an F. Follow that if you want. I chose not to, so that I just said false. Show military time. So that's 12-hour clock versus a 24-hour clock. So instead of 11 p.m., it might show, or would show 2300 hours, sort of thing. This is some stuff around if the two units aren't communicating between each other, what it's going to do, how long it's going to take till it resets itself or asks to reconnect, how long it will take for the clock function to kick in, because once your computer's turned off, it'll go to a clock setting in about 5 seconds. That's what I've got it set up for. This is some other stuff that for over the air updates, which if you're an Arduino fan, you probably know about. If you don't, it's stuff that you can just leave there, and the rest of it you can just kind of, it's there, and you wouldn't need to change it. So those are the main things that you would want to change on the Arduino side. So you just you plug your board into your USB cable and the cable into your computer, and you just click that, and it'll compile that and load it onto your chip. All right, so that's the Arduino side. The Windows side, I'm guessing most people aren't going to be as familiar with Windows and or not use Visual Studio. So I've written the program in VB.net. So you can go through that if you want to see what it's doing. Basically, it's using something called the WebSocket to connect to the Arduino. It runs not as an application on your desktop, but as a Windows service. So that's something you may not be familiar with either, but it's something that runs in the background. But I'll show you a little bit more about that in a second. But there's the code if you want to take a look at it. So what you'll probably more likely do is just download that either that executable file or that whole Git package, and it'll be in there. And then what we'll do is we'll just install it. So in Windows, kind of in the background, like so, like if I opened up Word, you'd see the Word application here, and it'd be running and be considered like an application that's kind of running kind of in your face. So there's other things that run on Windows that are kind of more in behind the scenes, and they're called services. So to have a look at all the services running in your system, just type services in there and press enter, and it'll come up with it. So right now I don't have the program installed. I'll just show you how to go about install it, but it's called the CPU Monitor Junior. And so you'll see there, it's not listed. So what I'm going to just do there is I'm going to go install it. So there's when you download the package, there's a folder there that's called install and uninstall files. So these have to be run from the Windows command prompt as an administrator. So I'm just going to show you how to do that. So I'm just going to go down here and type CMD and press enter, and then I'll have to do that again because that's not what I'm supposed to do. Type in CMD, click on here, and click on Run as Administrator. So I'm going to have to say yes to the Windows prompt there, UAC prompt, and there it is. It's running, and you can see it's running as an administrator. And what that does is gives you special authorities and controls that are needed to install the service. So here we go. I'm just going to take that and I'm going to change my directory to that. So the command to do that is I have to be on the same drive. So this is on my E drive. So I'm going to switch it to the E drive, and I'm going to CD open quote, and I'm just going to type or paste in that that folder name there, so that's going to be there. So if I was to ask for a directory of all those files, it would be these same files here. Okay, so the one I'm going to use is called _install. So what I'm going to do is when I type that, what it's going to do is it's going to take the, let me just show you here. It's going to take the program that's in the package that you downloaded. This is the one that I've digitally signed, and it's going to install it into your system as a service. It's going to also put a description on it, and this is going to tell it to start automatically when you turn on Windows. And this is actually I've remmed it out, so this is the net command to net start command, the one that you would normally use to manually turn it on. But I've built the install package so that as soon as it installs, it automatically runs it, and then this just tells you what time it is and will pause. So so what I'm going to do, all I'm going to do is I'm going to go in here. I'm going to have changed my directory here. I'm going to be running as an administrator, and I am going to type in here install, and I've got the underscore in front of it because I've got an underscore in front of it there. It's going to run that, and that's why is it not working? Install. I have to spell it right. There we go. So that's going to install it, and bang, Bob your uncle, it's done. So now if I go down here to my list of services that are running, and I refresh the screen, I should see my program CPU monitor junior. It's now running. It wasn't running before, automatically having started. So having done that, the program on the Windows side has now started running. It's reporting the kind of the CPU and temperature to the Arduino every second. Now I've got something here. I'm just going to bring it over here if I can. I can't bring it over. Okay, so it's just my CPU monitor. I don't know why I can't bring it over. Let me try again. Nope. Anyway, so if I was to show you my CPU monitor here, it's reading very low CPU usage, and in fact, when it's running, so right now I'm running my video recording software. It's at I think 4%. When that isn't running, it's generally it's 0 or close to 0. So the service running itself does not aggravate your CPU performance in a noticeable way. So there it is. There it's running. If you ever want to, for whatever reason, stop that. Here we go. Stop it. You just click it there, and you can I can just right click here and say stop. And what that'll do is it'll stop it from running, but it won't uninstall it. So now the next time you start Windows, it'll automatically start up again, unless you want to install it, which I'll show you in a minute. But you can, for whatever reason you want it to stop and start it, that's how you stop and start it. So there, its service is going to be running. So I've got some batch files here that you can type in _start and start it, and _stop and stop it. And then this guy here, uninstall, it just kind of uninstall. What that's going to do is it's going to uninstall, it's going to stop it. I got a problem today. Uninstall, there we go. And so it's going to automatically stop it and then uninstall it, and then it won't be on your system anymore. So there it goes, all done. So if I go back into services, and I do a refresh, and we'll find someplace here. It's not there anymore. So I'll have to install it after this video is done. So that's how it goes. So basically you put the unit together, you just plug it in and it works. You install this software on the Windows side. It'll automatically start communicating with the device. And then you should see your bar graph, working, pretty well immediately. It might take up to I think the setting was 15 seconds or something for it to repoll. But once it's got it, it'll keep updating every second. So the last little piece I want to show you then is, and this would be for people that have access to a 3D printer. that in the GitHub package, there's also some files that allow you to print the box. And actually, I spent more time, to tell you the truth, doing this silly box than I did on the software, because I'm kind of not used to. I'm using Fusion 360. It's kind of like an AutoCAD thing, and I'm not used to it fully. So it's taken me a while to build it. And so I'm going to include the source, not only these files for the STL files, which are the box files, but the kind of the source for the Fusion 360. So if you want to use them or change them, you can. But basically, it's just a box, and this is. I'll show you that there's a faceplate on the lid. But basically, you put the ESP on these 4 posts, and you put the real-time clock, if you want one, on these posts here. Now the real-time clock, it actually has holes in 3 places, but not in the 4th. I don't know why that is, but that's what they've decided to do. So this is just to kind of rest it and make it level. And then so the idea of this here is you put it on there, and you can imagine the board coming up to about this high. So I've tried gluing PCB boards to this. I printed this with PLA. They don't really stick very well, I found. So what I found does work is you just kind of place the board on these posts, if you will, and then with the board on these posts, just take your tip of your soldering iron and just kind of melt the top of the post here down, and it kind of melts it onto the board, if you will, and then the board is secured onto the platform of the box, right? So that's the box itself, and there's also a faceplate. So you just give me a second here. It's going to pop up. All right, so there's a faceplate there, and just oops, I guess I must have hit it twice. It's going to just put the faceplate there, and you can print it as well. So when you get one of those LCD, I might even have one here someplace here. I've got one here. It's a blue one. So it's got the pins along the top here, and so it needs a little room here, and you can see that this would fit in along the top here. So there's only one side that kind of fits up, so it'll only fit in one way. And there's also a little backlight thing that goes here, so there's only one way to put that in, so you'll figure it out. And then the pins on the back of the board here, I don't know if you can see that well or enough, they kind of stick out like this. So when you put the connectors on, the DuPont wires, you need to bend it carefully so that they're kind of at 90 degrees to the board, so that it'll fit in. Otherwise they're kind of sticking out like this, and what you want them is you want them sticking out in towards the center of the box. And that's about that. And then the lid is pretty easy. So the lid is just slides on top of the box. So you put the faceplate into the box, and you can glue it if you want. That you can use like super glue, like some super glue here, or some Gorilla Glue or something to put the faceplate and glue it into the box if you want. You don't have to; it'll hold there by friction. And then this is the lid, and so the lid is, you're going to print it top side down. So on the bottom of it, there's a little arrow here, and that's just to help you understand which way to kind of slide the lid. So the lid slides towards the back of it. So you just put it in, you slide it in, and it works. Anyways, like I say, I spent a lot of time on this silly box and lid and faceplate, so it seems to fit well together. So that works too. So anyways, that's kind of the whole kit and caboodle. It's been a long video. I appreciate your staying with me, but this is kind of the end goal, and hopefully if you get that going. Oh, you know what? I should mention too. So my PC has 8 virtual cores in it, right? So it's showing 8 there. So if you have a more modern PC or one with more cores, the program can handle up to 16 cores because there's 16 columns here, and there's some logic in there that'll automatically turn things off. And what you do is you'd kind of tweak the Arduino side, but by default it will work up to with 16 cores. But if you put the 16 core connection in, the percent busy here and the temperature will not show on because there won't be any room. Now the Windows machine, when it's communicating with the Arduino box, it tells it how many cores your PC has, so it's not a setting you have to set. So it'll do that automatically. So if you have a 16 core machine, you might want to look into the instead of the 2 rows by 16, the 4 rows by 20. So that'll give you enough room to show all your 16 cores with 4 extra characters on the end, which I use to display again the percentage busy and the temperature. Although the temperature, to fit it into the 4, I take it down to just these 2 digits and around it. So, anyways, so that's the long and the short of it. Hope the project will be of interest to you. If you have any comments, you're welcome to send me a note at I think it's info@arlatour.com, and visit the site. I'll have it up there in a while, and it'll be something that you can do on an afternoon maybe. Okay, thank you very much. Hope that'll be a good use to you.